I was hoping I'd have my microphone later.
I told you to woman. We had
How does my hair look? How's my hair look?
Mission Control, this is STS Mustang. Pierce here. We have a problem. Do you read?
Oh, you silly! Don't bother those nice people there. Just pull over and let me have the map. I'm trained to read a map, Commander. I think I do. Sure, I got it. Oh, look! I found the map of Texas. Go me!
Mission Control, do you read? Mission Control, do you read? We have a problem, and it appears our gravitational instrumentation is not calibrated correctly. Or we are way off our trajectory towards Earth.
Yes, Commander, we read you. It appears the STS Mustang is adrift traveling at a speed of 17 billion kilometers per hour and has a vector reading of 283.354 Mark II. Do you read the same?
Wilco, Mission Control, we read the same. We are lost in space, March. We need to determine our position and align the STS Mustang with a new vector heading to get home.
Oh dear. Will I be going home late? I told my husband I'd be home on Friday for dinner. It's meatloaf night. He so looks forward to meatloaf night. You think you like meatloaf, Commander?
Do you have any inclination that we are lost in space and may become part of the stars by Friday?
Must you take that tone with me? I'm here to help you, Commander. I can see Texas. Go me!
A map is for land, March. Land, not space. We need to use the spectral analysis and parallax to find our location.
Oh, Commander, you need to get out of the simulator every now and then. We can navigate by the stars.
Aren't the stars? You're right. We can use the EM spectrum to find our way home.
Aren't the stars so pretty, Commander? I like pretty. Mission Control, this is Astronaut March.
March, we read you.
Oh, I read too. What are you reading?
You being lost in space?
Ooh, you have a sense of humor. I do too. Well, Mission Control, Commander has lost us again. It's meatloaf night, and I need to be home by Friday. Can you help us get us home?
I don't know anything about meatloaf night, but we can use the electromagnetic spectrum to find your location.
The electromagnetic spectrum? What is that?
That's the EM spectrum I was talking about earlier. It includes all wavelengths that can carry energy in the form of radiation. You know, like radio waves, microwaves, infrared radiations, Roy G. Biv, ultraviolet radiation, X-rays and gamma rays.
Roy G. Biv? You mean a person is part of the electromagnetic spectrum?
Roy G. Biv stands for orange, red, yellow, green, blue, indigo, and violet.
Just like a rainbow. I like rainbows. You like rainbows, Commander?
Each star emits its own combination of wavelengths in the EM spectrum, and we can use that unique combination to identify them.
So it's kind of like a fingerprint.
But it's much more than that. The EM spectrum can also tell us to give us information like what stars are made of, its temperature, size, and even how old it is.
Wow, that is so amazing. Mission Control, what stars do we need to locate to find our way home?
You will need to locate Polaris and Cirrus A.
Mission Control, I don't think we're likely to find a four-wheeler with a radio out here.
Those are stars, March. Polaris is the North Star, and Cirrus is the brightest star on Earth.
Okay, don't get your panties in a bunch.
We know Polaris is a supergiant, and Cirrus is a main sequence star.
We do?
Well, at least I do. Supergiants are red in color and really bright, so that should be easy to find.
Well, how do we know that?
It says right here in my Hertzsprung-Russell diagram.
What are you talking about?
If you would attend a mission briefing every once in a while, you would know the HR diagram classifies stars based on temperature and brightness. Look over there. That star is red. According to my spectrometer, it's extremely bright. Compare this star spectrum to that Polaris.
Wow, its spectrum actually matches that of Polaris. One down, one to go. How are we going to find Sirius?
Mission Control, can you give me some data about Sirius? I know it's a main sequence star, but what is its temperature and brightness?
According to what I have here, its temperature is 9,940 Kelvin, making it a light blue star and a luminosity of 25.2 lux.
Roger that, Control. We are on the lookout for a star matching that description. March, do you see any stars that match that description?
I see tons of stars, Commander.
Well, main sequence stars are the most common type. We were headed in the general direction when we got lost, so it should appear to be one of the brightest stars around because we are so close to it. So let's look at the brightest ones first.
I found it! I found it!
Where?
Straight up ahead, straight in front of us, Commander.
Good job, March. Now let's see if the spectrum matches what we have in the computer for Sirius.
You mean that fingerprint thingy again? Its fingerprint matches? So we're saved? We're saved!
Not quite yet. We still have to use this information to locate our position. Let me radio it to Control. Pierce, Mission Control.
Mission Control, we read you loud and clear, Commander Pierce.
We have the location of Polaris and Sirius. Polaris is located at coordinates 121.257.3 Mark 5, and Sirius is at coordinates 96.350.80 Mark 3.
Roger that, Commander. That gives us a vector heading home for you of 251.141 Mark 2 at a distance of 19 trillion kilometers.
All right, we can head home and make it in time for Meatloaf Night.
March, that is a little over 2 light years away. You will not be home in time for Meatloaf Night.
What? What? I guess next week we'll have to do.
That's 2 light years, and this ship does not even travel at the speed of light. It may be years before we get home.
So you're saying the meatloaf won't be good by then?
Mission Control, we are headed home. I think only one of us will make it back alive.
The end.